Good morning everyone. My name is Shiva Krishna. I am from Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the free vibration analysis of an undamped systems. So previously we have seen about the how the multi degrees of freedom will be works and what is the different types of equation that will be have been generated from the multi degrees of freedom. Okay. Now we are going to see about the undamped systems. Analysis of undamped. So in this undamped system we have seen about the F1, F2 forces and the multi degrees of freedom. If we take that F1 and F2 as a zeros, there is a force is taken as 0. Here F1, F2 equals to 0. If we are taken, that will be called as undamped systems. So in this harmonic motion, M1 and M2 has been same frequency has been taken, and the phase angle will be taken as 0, phase phi, and we take the solution as per equation here. So for these equations, if you want to know about this previous equation, how it is generated, so you need to check this previous video, which is undamped system and introduction to this equation of motion. Once the degrees of 2 degrees of freedom has been understand, we come to this undamped systems once again. So here undamped system means there is a force has been taken as 0, and this equation of motion we have been taken as the same frequency. The two masses M1, M2, which is taken as a x1 and x2 directions. Okay, these two systems has a forces equals to 0. Forces equals to 0. Then these equations will be going to come, but the frequency, natural frequency as well as the phase angle will be going to taken as the same equations. Same. Okay. Now x1, x2 contains the denotes the maximum amplitudes of this x1, x2 of x2 within 5 angle. That is x time 1, x time 2. We have been taken with the same phase angle, and substituting these two equations into the first equation of motion, then we are having like this. So here we have been taken with the cos values. Cos we have been taken as 0 here. X1 equals to xt of t, x of t we have been taken as x1 into cos omega t plus phi value, and x2 we have been taken as x2 into cos omega t plus phi value. So this equation has been taken into this form of x1, and again in this x2t. So here it is x1t, x2t we have been taken, and we have been inserting into this equation under undamped systems. So once we inserted and rearranging this equation in the form of, we have been taken as a minus m1 omega square plus k1 plus k2 of x1 minus k2 into x2 and cos of phi t omega t plus phi, and which is under this equation 1. And equation 2 as the same thing we have been taken and as included into this equation of phi angle and natural frequency as same. So here it will be going to be minus k2 of x1 plus minus m2 omega square plus k1 plus k2 of x2, which is under the masses equation and damped equation, and we are changing this as a x2 we have been changing as a cos of omega t plus phi, which is under the equation 2. So since the above equations are satisfied with all values of real time values, and the terms between this bracket must be 0, so which is under this must be zeros, which is we can able to say that this is going to be 0. So all these terms are going to be 0 within these brackets. Okay, within these brackets is going to be 0, and which represents the multiple simultaneous homogeneous algebraic equation, which is homogeneous algebraic equation as unknowns of x1 and x2s. x1 and x2s we are having here. x1 and x2s we are having here. So these values need to be found from this above equation. Can we satisfy the time intervals of x1 equals to x2 equals to 0, which is we have been taken as a x equals to zeros, also x equals to zeros, which implies that there is no vibration because the force is not zero. There is no force, then vibration will not be occur. In this undamped name itself, it is saying that the force equals to 0. The force equals to 0 means if there is a force, then only it will be going to be vibrate, right? So from this equation also we can able to say that there is a no vibration we can observe from this equation. It is a homogeneous algebraic equation. Once it is taken as x equals to 0 and y to x equals to x1 and x2 equals to 0 means there is no vibration is occurred because of there is a force is 0. If there is no force, automatically the vibration will be going to be reduced, or it's 0 it will be. And non-trivial solution of x1 x2 determine the coefficient of x1 x2 must be zeros. So it will be a 0 equation will be going to come into this undamped systems. Understand? So coming to the free vibration analysis of undamped systems. So we have been taken as a previous matrices form. So here we are taking into terms of det of previous values, which is under this equation. Under this equation we have been taken as a det. So det of this one we have been taken as a minus m1 mu omega square plus k1 plus k2, and second element as a minus k2 and third element as a minus k2, and here m2 of omega 2 omega square plus k2 plus k3. So here is some small things we need to be remember. It will be m1 and m2 and k2 will be same. Here is the first box will be having content with the m1 m2, it is a k, it is a k, k1 k2 and k3. So it will be implies in between k1 it is in the first matrices and k2 will be under second row. Okay, it will become under k1 plus k2, and in this also k2 plus k3 will become at this second. So it will be attached to this. K2 will be has been divided into first part and second part. Okay, first part and second part has been divided. So you need to be understand while taking this as a matrices. Okay, so this equation we can able to write it in terms of det equation. So it will be comes under this to the power of 4. So m1 and m2 it will be cross multiplication of this. Okay, AD minus BC it will be going to comes. So once if it is multiplication is done, AD minus BC if it is there, then it will be m1 into m2 into to the power omega to the power of 4 and minus of k1 plus k2 into m2 plus k2 plus k3 into m1. So it will be under this both, it will be comes under omega square. Omega square will be the natural frequency of this particular thing. Okay, particular frequency about the k1 plus k2 and k2 plus k3, and omega 1 plus k1 plus k2 multiplication of k2 plus k3 of minus k2 square equal to 0. This equation is called as a frequency or characteristic equation. Characteristic equation we need to be remember once again. So this is very important characteristic equation as a compulsory problem into the coming sessions. So we need to remember all this equation once again. So it will be called as a frequency or characteristic equation because of the solution is in this used to the frequencies of the characteristic value system. The roots of this above equation will be given by this. We have this omega to the power of 4. Omega to the power of 4 we need to be divided into 2 times because we need to be find the solution for this. Right? Omega natural frequency we need to be find it as a complete equation to the power of 4 if it is there. So we need to be generalized equation we need to be say that there is a square c should becomes, and after that then there is a single omega should becomes. There is a value we need to be found it. So that is we are having minus b into minus 2ab 4abc. So this equation is there. My roots under form is there. Plus or minus under root it will be there, right? So that is a under root we have been taken as a here. Okay, under root we have been taken. So PD 2ab minus 4ab PC minus 2a it will be going to come under this equation, roots equation. Okay, which is under the identical will be there. Okay, so from this equation as a roots, so we have been already said there is a possible of the system for this non-trivial harmonic solution for this x2 x1 and x2. Already we know that x1 x2 values, x1 of t equals to x1 into cos omega t into pi, and x2 equals to x2 of t equals to x2 into cos omega t into phi. Okay, which will be we need to be know that as a equations of x1 x2 we are already included in the equation previously. right? Already included. So when omega equals to omega 1, omega equals to omega 2 is given, so it will be going to be taken as a some equation will be going to be reduces. Once it will be going to be reduces, then it will be easy to solve for our understanding purposes only. So it will be going to be solved as a omega equals to omega 1, omega 2 equals to given by, so it will be under root of plus or minus, it will be going to comes like this, minus 4ab by 2abc, right? So it will be comes under this equation. So we shall denote the values of x1, x2 corresponding to this. Omega 1 equals to as a x of t of power 1, and x of 2 x2 of power 1 we have been taken as a x1 x2s, and corresponding values we have been taken as a omega 2 has been taken as x of 1 and x of 2 have been taken to the power of squares we have been taken. So it will be 2 means here 2 will be this is omega 2s, okay, to the power, you can check this in brackets, 2 will be omega 2, and here it is a 1 will be the power 1 equals to for this omega 1. There is a mass 1, mass 2 values we can able to say that is in the denoted values x1 and x2s, right? So since we are having all the equation, since we are having all the equation, we can able to find the roots values and we can able to find the complete omega values. The roots values we can able to emerges in the form of we can able to write it in terms of x1 x2 of 1 by x1 of power 1. So here it is a 1 by 1 only, here it is a x2 by x1 for the 1, okay. Root 2 we can able to write it as a x2 by x1 to the powers, you can say there is just 2 only. So it is the mass 2, you can say there is a mass 2 and it is the mass 1, okay. Yes, mass 1 and mass 2, x2 by x1 we can able to write it, okay. x2 by x1 we are writing about this. So if we solve all those things, if we solve all this, and we are taking omega square equals to omega square 1, omega 2 equals to omega square equals to omega 2 square, okay. The same thing we have been repeated most of the times. So here we have been taken as r1 equals root 1 equals to minus k by omega minus m2 of omega square 1 plus k2 plus k3, and root 2 we can able to write it in terms of k2 by minus m2 omega square of 2 plus k2 plus k3. So which will be under this ratio since we taken as identical forms. So it will be under two identical forms we have been noticed that, okay. Now we can able to write in terms of corresponding modes, that is omega values we can write it. So we can able to represent in terms of, so here x1 we can able to write it in terms of mass 1s, mass 2s, okay. If it will be good if you say that is the mass 1 and mass 2s, okay. Mass 1 values, mass 2 values of the distances, okay. x1 values we can able to write it in terms of x1 x2 which is under the mass 1 effect, okay, forces into wonder effect, okay. Again x2 will be taken as in terms of distances that will be moved under this representatives. So we have been included as a root value here which is under the real condition. If you say there is a force has been applied under this, r1 reaction or r1 root will be going to come. F2 if you are applied, r2 root will be going to be generated. Like this generation we need to be know. And the vectors form, in the vectors form x1 of bar and x2 of bar we can able to denote the normal modes of vibration known as mode vector systems, okay. The free vibration solution of the motion that can be expressed, time can be used for this expression. So we have taken as a x1 of t equals to x1 into cos omega t into phi, we have already seen that, and we can able to write it in terms of which is initial conditions, which is under this initial conditions, first mode and second mode. You can check this as a x bar of t vector mode, we can take as vector mode of take it x1 vector into the time condition we have been taken as x1 of t, and x2 of 1 we can take it, okay, under the time conditions. So we already said there is a root value we have been found under this. So x of t we have been representing again in terms of x1 into cos omega plus phi angle. So we just included into this first mode value, and again in this r2 of x1 to the power of 2 we have been taken into the here. So which will be under the second mode. So under the value of M1 and M2, there is a mode. Here it is a mode. First mode and second mode. There is a forces we have been represented as per. So here it is a M1. We can take it as a mass 1. We have taken as a mode 1, and mass 2 we have been taken as a mode 2. So we constantly say that there is a x1 and x2. Sorry, x1 of 1, x1 of 2, and phi of phi 1 and phi 2 determined by the all initial conditions. So here into this phi 1, phi 1, phi 2, phi 2s, and again there is a x1 values of 1, x1 values of 2. In this, these are all the initial conditions of this mass movement motion. Okay. So from these initial conditions, the each equation of this motion we can able to write it as m1 x double dot plus c1 plus c2 of x dot minus c2 of x dot 2 and plus k2 plus k3 of x1 minus k2 of x2. k2 of x2 we can able to write it in terms of forces. So we already say there is a equation of motion from the free body diagram. Free body diagram, right? Free body diagram we have been taken. So from this free body diagram, we know that there is F1 and F2. The forces on this mass 1, mass 2 we have been taken, which involves second order time intervals, which have been taken as into the two initial conditions for the each values. Two initial conditions we have been taken. The system can be made vibrate under this normal modes of I equals to. We have been taken as a in I equals to as a imaginary parts of 1 and 2 by subjecting these specific initial conditions as a previous equation. This one equation we have been taken as into 0. That is the forces we have been taken as undamped systems, right? However, for any general initial condition, the both modes are excited and resulting motion which will be given by this general equation. So can be obtained linear superposition of these two normal modes also. We can able to obtain again for this natural superposition also we can able to apply in these two natural modes. So in this initial condition, x of t equals to c1 of x1 of t, okay, and c2 plus c2 of x2 of t we have been taken as a initial conditions where c1 c2s are constants. So here x1 of t, x2 of t we can take it as a initial conditions for the movement of these undamped systems. Since x1 of power 1 t, x1 of 2 power 2 of t, which is already involved with the unknown constants of this. So here it is x1 of 1, x1 of 2, we can choose it as a 1. We can choose it as a 1, or there is no loss of generality. So these corresponding points will be taken as a vector point of view. This vector point of view we can able to express. So all this comes together, we can able to say there is a x1 condition at the time 0. At the time 0, x1 value will be 0, x2 value will be, there is the distance movement into this m1 m2 distance movement. Okay, it is the x1 and x2. When there is no forces acting on this, there is no distance has been moved. From this, all this equation will be going to be generate only this one, the exam m1 and m2, which is time 1. There is an initial condition at the time 0, which will be x equals to 0. At this x dot equals to 0, there is no distance, means already there is no velocity will also be occurred. So x dot means there is a velocity will also be at the 1, at the 2 will be 0. So at this there is no force equals to 0, and there is no force 2 equals to 0. Okay, into this m1 and m2, if it is connected with this k, and k2 is there and k1 is there and k3 is there, all together we have been taken under these submissions. So at there is a condition, the phase value has been determined, everything has been taken, and here only thing is here we do not having anything as a force value. So generally once there is a force, then there will be going to be a distance will be going to occur. Once there is no force, there is no distance has been occurred, and there is no velocity will be going to be occurred. This is what we know about this undamped system equations. So here undamped system vibrations we have been taken as a phase values as zeros, and equation initial conditions we have been taken as zeros. At this particular point of we have been taken. As a constant, the phase 1 value, phase 2 value can be found by using of the solution for this equation as obtained from this, Once there is no forces also, there is a phase value will be going to be generated, because of there is a natural frequency is there. Natural frequency, if it is obtained, we can able to write this as a phase values, phi 1 and phi 2's. Okay, phi 1, phi 2 values will be there automatically. Okay, once the, because it can able to generate that much angle, so that's why we need to be having this phi 1 and phi 2 values, because if there is a slide is there, okay, if there is no force also, it will be going to be move, right? There is a smoothing surface also there. Once there is no forces, if it is occurred, there is a movement will be automatically, slowly it will be generated because of the slopes, right? So like that, we can able to have a slope values as a phi values is there. So like these conditions, we can able to generate as a phi values here. So cos is there for this initial conditions, x1 and x2 is equals to 0. There is a distance is equals to 0, and velocities we are having as a phi values. There is a value will be there as per this. Forces is not generated, but there is a phase angle has been generated because of this smooth surface or identical conditions. That's why we have been taken I equals to 1 and 2. We have been taken as a previous slide. Just you can check this. The I value have been taken as this identical condition. The normal mode we have been taken. So right. So here we have been taken as in terms of phase values. We can able to find it. Right. So all these things under the damped conditions we have been taken. So phase values under this x1 of t and cos values, just from this equation, we need to be go to this equation and solve it as this as a, we can able to get this r1 of x1 naught and x2 naught equals to x2 naught by r2 minus r1, and x1 equals to x1 of 2 equals to cos phi value will be going to be minus r1 into x naught plus x2 naught 1 by r2 minus r1. So these values will be comes under this phase value conditions. So once if we go to this, which will be determined by observation of this, we can able to obtain as a phase values conditions as this. So these are the values of this tan inverse of x1 of 1 x1, x1 of 1 sin phi, x1 of 1 cos phi, which is under the phase value 1. Again, we can able to write it in terms of x1 equals to, we can able to write it in terms of x1 sin 1, we can able to write it in terms of r1 r2 also, right? R2 of x dot of 1 of 0. So here these equations you need to be remember, others you need to be practice for the summation problems. So mostly these type of problems will be going to become as a higher end semesters. Higher end semester means we can able to obtain into this MTechs also. So mostly you need to be know how it has been occurred. So that's what we have been derived all these things. So thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.